Greetings everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Together we strive for a change through education. Ladies and gentlemen, I want to take you through the second session for the complex numbers, where we'll be talking about the complex numbers that are in polar form. Ladies and gentlemen, in the first video, we went through the complex numbers that are in rectangular form. Now, in this session, we need to actually deep dive into the complex numbers that are in polar form. Without wasting time, ladies and gentlemen, let's now start with the session. Right, at the end of this session, one must be able to understand the standard form of a polar complex number. And also you need to be able to solve problems using these complex numbers whenever we're dealing with addition operations, subtraction, multiplication, and also division, and also be able to understand De Moivre's theorem and also its application. Right. Without wasting time, ladies and gentlemen, let's now start with the session. Right. Number one, I want us to first recall on what we have covered in the first video for the complex numbers that are in rectangular form. Right, we have seen that when we have a complex number that it is in a rectangular form, the complex number that is in a rectangular form, it's always written in the form of Z equals to A plus BI, whereby the A is the real part and the B, it is the imaginary part. Right, and we have seen that we can represent this complex number that is in a rectangular form on a diagram called the Argand diagram, where we had on this Argand diagram, we know that the x-axis is called the real axis, and the y-axis, it is the imaginary axis. So we know that on the real axis, we only represent, or we only show the real values. So it means if we assume that this is the A value, and this one, it is the B, it is the imaginary value, then we're gonna look at where the two point, like the point of contact, then we construct a line up until that point. So this is actually the Argand diagram. This is what we have already done in the first video. Then we said that we can now draw the angle from the positive real axis up until it touches the line, and that is called the theta, and that is called the R. Now, ladies and gentlemen, I want us to now continue to say, now we know that we can be able to write a complex number to be in a rectangular form with A plus BI. Then now I want us to continue with the concept of polar form. So it means, in other words, complex numbers can be represented in two ways. Number one, we can represent it in a rectangular form. And secondly, we can represent a complex number in a polar form. So we can write a complex number to be in a rectangular form or to be in a polar form. So now, which means that we have already seen on how to write the complex number to be in a polar form. Let me say to be in a rectangular form, we need to change it to now be in a polar form. Ladies and gentlemen, to do that, it means we have to analyze everything. We have to analyze using what you call an Argand diagram. Let's consider this. We have seen that on an Argand diagram, we have the value of A and we have the value of B. So which means from this Argand diagram, we can actually focus on what you call a right-angled triangle. So let me just try to redraw this so that we can be able to understand. Remember I said from the origin, this is called the R. We spoke about this. And this side, it is the theta. It is actually the theta, which we'll talk about. I'm referring to this. So since it's the theta, if we construct this, then we're going to have a right-angled triangle. So which means if we have a right-angled triangle, then the vertical part will actually be the distance, which will be from B up. So this will be B, and this one will be the A. So we now know that from this point up until here, this is the A value. It is the A, and this one is now the B. So now, which means that we can do this. We can say now, since we are able to identify the real part and the imaginary part on this right angle triangle, let's now incorporate this right angle triangle with trigonometric ratios, with the trig ratios, which you call them the SOHCAHTOA, which you call them the SOHCAHTOA. So which means that we can say, because we are able to identify this, we can say, okay, fine. If we were to use the sine of an angle, we know sine is opposite over the hypotenuse. So what is the opposite of the angle theta? So obvious, the opposite, this would be the opposite side, and this one would be the adjacent side. So we know the opposite. What is the opposite? The opposite is the B, and the hypotenuse is the R. Let's now make B the subject of the formula. So making B the subject of the formula, it means we can say B equals to R sine of theta. So we can now determine the value of B in terms of sine theta. Let's now do the same. Let's now do the same to determine the value of A. Obvious, to determine the value of A, it means this time around we're going to use the cos of theta. And what is the cos according to SOHCAHTOA? The cos is, I apologize, the cos is adjacent over hypotenuse. And we can say we have cos of theta. What is the adjacent here? The adjacent is the A, and the hypotenuse is the R. That's over 1. Let's now write determine the value of A in terms of R and theta. So this, the A will be R cos of theta. So we have determined the value of A, and we have determined the value of B in terms of the R and the theta, which means that from the rectangular form of a complex number, we can say now, we know that Z, which is our complex number, is equals to A plus the BI in a rectangular form, which means that where there is A, we can substitute A by using the R cos of theta, this one. So it means now we'll have the following. So it means the A is the same as R cos of theta, plus the B, it is the R sine of theta, but already there is an I. So which means if we simplify this, we are going to have a common factor, which is the R into the cos of theta plus I sine of theta. So which means this is another standard form of a complex number. And this standard form of a complex number, it is the one called a polar form. It is the polar form of a complex number. So which means, ladies and gentlemen, since I said there are two types of complex number, we have a rectangular form and a polar form. So which means now we can conclude by saying a rectangular form should be in the form of A plus BI. A rectangular form is in the form of A plus BI or BJ. Then this is in a rectangular form, but we can change the rectangular form to be in a polar form, which is now written as R into the cos of theta plus I multiplied by sine theta, which these expression can be written in short as, we can write it as the R C's of theta. So if we write the R C's of theta, we know it's the R, the cos. The first one, it is the cos, and the I, and also the theta. So I'm saying the sine, I apologize, the sine of theta, which means that we can now be able to write a complex number to be either in a rectangular form or to be in a polar form. But if we are writing this complex number to be in a polar form, this can also be written as the R, then with this symbol, then here it's theta. So it means it's the Y is the same thing. If we write an expression in this form, it's already in a polar form. Now, therefore, it means you must be able to know what is the R and what is the theta. So the R is called the modulus. The R is called the modulus, and the theta, it is our argument. So we have the R, which is the modulus, and the theta, it is the argument. And this theta, it's actually an angle that is measured from the positive real axis up until to the line. It's almost the same, or it's related to what something called the angle of inclination from analytical geometry, right? Which means now, ladies and gentlemen, we've seen that we can write a complex number to be in a rectangular form or to be in a polar form, which we'll talk about this. The question is, how can we actually convert it? How can we determine this R and the theta? Right, I'm going to draw this Argand diagram to say, in the Argand diagram, remember we said this is the imaginary and this is the real axis. So if we construct we represent the complex number in an Argand diagram. Remember, this should be the A and this one should be the B, which means from here up until it's B unit, and that's a unit. So right, then it means this will be the theta. So which means the R here would be the modulus. So which, since this is a right angle triangle, if we can use the theorem of Pythagoras, we know that according to the theorem of Pythagoras, it says the sum of the square of the adjacent and the opposite must be equal to the square of the hypotenuse. So which means if we take this as the X and this one as the Y, which means the X here would be the A and the Y would be the B, then the R is the modulus that we're looking for. So which means if we rearrange this R squared will be equals to A squared plus B squared. Then we can put the root sign here. So which means that to determine the value of R, we use the square of the A, which is the real part on the rectangular form, then the B squared. So this is actually the formula for calculating the modulus. But now if we wanted to calculate the argument, which is actually the angle, so we're going to use tan, which is tan of theta, its opposite over adjacent, and the tan here, the opposite will be the B, the adjacent will be the A. So which means to calculate the argument, we use second function tan, which is the arctan of B over A. So we are going to solve algebraically and also confirm by using a calculator. For example, ladies and gentlemen, you need to be able to, okay, let me just do one simple example so that we are able to confirm or to actually understand the difference between the rectangular and a polar form as the type of a complex number. Let's just do one simple example. Imagine we have the following. We have the z equals to, let's say, 2 plus 3i. The number one, if we look at this, already it is in a rectangular form. So if we construct the Argand diagram, it means we're going to have something like this. So this will be the imaginary axis, and this will be the real axis. So it means from here, the imaginary would be 2, and the real axis will be 3. So we're going to have something like this. So we're going to construct a line from the origin. So this is actually the R. This is the R. And here we must have the theta. Already, if you look at this theta here, this is the argument. It's already less than 90, which is, it is an acute. So it means the angle that we're going to get here should be less than 90. And to do that, we're going to say, okay, fine. We're going to use theorem of Pythagoras to say the R squared equals to the X squared plus the Y squared. And now to do this, we know the R squared is our modulus. Then the X is the A, which is the 2 squared plus 3 squared, which will give us R squared equals to 4 plus 9. And the R squared will be equals to 13. So which means the R will be the root of 13. R is always positive. So this is called the modulus. We already have the modulus. Then now we have to calculate the argument. And to calculate the argument, we're going to use the tan. So we're going to say the tan of theta, it's B over A. And this tan of theta, what is the B? The B, it is the 3. So we're going to have 3 over 2. Then to calculate the theta, we make the arctan, or the second function tan of 3 over 2. Then let's now calculate the angle, which means the angle that we're going to get here, it should be an angle less than 90 because it is in the first quadrant. Our Argand diagram, so it's going to be second function tan of 3 over 2. So which means the answer is 56.31. So 56.31. So which means now we can now convert the complex number to be in a, I'm saying yes, from rectangular to a polar form. And to do that means we're going to say we have the z equals to the r into the cos of theta plus I multiplied by the sine of theta, which is the same as the r cis of theta. And or we can just say r with this symbol, with, so it's one the same thing. So it means now what is the r? The r is the root of 13 cis of, what is the theta? The theta is 56.31. 56.31, ladies and gentlemen. So this is what you actually need to know when you have to convert from rectangular to polar. So it depends with the equation. Sometimes they will say convert from polar to rectangular or from rectangular to polar. So these are the things that one must be able to know when you are dealing with a complex number. But now, how about if we have this? Let's just do another example. How about if, let's say, we have the second complex number. Let's say we have minus 3 plus 5i. We need to know what is the modulus and what is the argument. Right, let's do this, ladies and gentlemen. Let's construct an Argand diagram. So when we construct an Argand diagram here, we know this is the A and this is the B. Remember, this is the real part and the B is the imaginary. So we have the real axis and the imaginary axis. So what is the A value? The A value this time around, it's -3. The B value, it's 5. So it means now we're going to have something like this. So this is the point. So it means now we're going to have something like this. So this is our Argand diagram. But how are we going to represent the angle? The angle must be represented from the positive real axis up until it touches the line. Remember, always we measure positive angle anti-clockwise. So which means you can see that the angle that you're looking for here, it's already bigger than 90. It's already bigger than 90, unlike the first one. So which means now we're going to do this. We're going to say, okay, fine. Let's now determine the value of r. So we're going to say the r squared equals to the x squared plus the y squared. Then the r squared, the x is the a, which is the -3. Then the y is the b, which is 5. So we're going to have r squared, which is 9 plus 25. I apologize. 9 plus 25, which will just give us 34. Okay, let's just put 25. So it means the r squared will be equals to 34. So which means the r, by putting the root sign, will be the root of 34. Now we know the value of r. Then now we need to determine the value of theta. To do that, we're going to say theta, it is the second function tan of b over a. Let's do the calculation. Then the theta will be second function tan of, what is the b here? 5. And what is the a? -3. We put everything there. Then now we're going to do this. We'll say theta equals to, then we make second function tan of minus or 5 divided by -3. Then this will give us a -59.04, which means this is not the correct answer, because this -59.04, it means is the angle that we have measured, but moving from this side anti-clockwise there. So this is the negative. So it means if we want the positive one, what do? We need to add this angle by 180, like what you have learned in trigonometry. So we add this angle by 180 degrees. So it means this would be a -59.04 plus 180. So this is how much? 120 degrees, 0.96. So it means from here up until there, this is the one which is 120. So you need to be able to understand this, ladies and gentlemen. But however, you need to be able to also be able to use the the scientific calculator to convert from polar to rectangular, and from rectangular to polar form, from rectangular to polar form. Remember the first answer, the first example, we got √13 with an angle of 56.31. Then the second one, we got √34 with an angle of 120.96. But now I want us to also look on how to convert this using a calculator, how to convert this using a calculator. Right, let me try to display the financial calculator. Remember, calculators do differ, but here I'm just using an online one. You can use any scientific calculator, but remember the calculators do differ. Now, what I wanted to do here, we are going to do something like this. Let's say within what, based on what we have done already, I'll start with the first one of 2 plus 3i. What was the r? The r was root 13 according to the calculation, and the argument was 56.31. Then the second one, which is minus 3 plus 5i. Then now these, what was the r? The r was the root of 34, and the argument is 120.96, or we remember we said minus 59.04 if it's a negative angle. All right, then now I want us to confirm these answers using the scientific calculator. Right, on this scientific calculator, there are two things that I wanted to guys to look on. The first one is the one that I've circled there, the pole and the rec. So we have something called pole and rec. Right, the function pole, actually, we use it to convert from rectangular to polar. So if it means if we want to convert from rectangular to polar, we use pole. But if you want to convert from polar to rectangular, we use rec. But now look at these guys. If we are converting from rectangular to polar, it means we need to use the parameters of a rectangular form to compute the polar. So it means as a syntax, we're going to say, to calculate the pole, is going to say the pole will require the value of A and the value of B. So we need to know the value of A and the value of B to change from rectangular to pole. But if we are changing from polar to rectangular, it means you're going to say the rec, it will require the R and the theta. So it will require the modulus and the argument. So first of all, I'm gonna do this. I want us to compute what is called to change from rectangular to pole. And to do that means we're gonna say shift, because we want to get this pole function here. We want to get the pole function, which is on this, it's where there is a plus sign. So it means we're going to say, we first press the shift together with the plus, then we'll have to see that. You see, it's showing the pole function that we say, this pole requires the value of the A and the value of the B. So to do that, we're going to insert the value of the A and the B. What is the A here? The A is 2, so this is the A and this is the B. So we're going to press, first of all, we'll have to do this. We'll come here, then we first do this. Let's put the value of A. To put the value of A, then we're going to press 2. Okay, let's press 2 there. You see, 2, it's already inserted there. So we have the value of A. Now let's put the value of B. The B, I'll just press 3 there. Let's check what is going on. You see, it says 23. So it means now I have to come this side. Then now I have to put 3. Then now press equals to. And when I press equals to, ladies and gentlemen, let's check the output. You see, it says that your R is the root of 30. You see, it's showing this symbol, the one that I said. This is the symbol. So the R, it's root 13, and the theta. So this is the R, and this is the theta. So the R, it's root 13, and the theta, it's 56.31. Now, let us change this and say, this time around, we are changing. So what is the A now? The A is negative 3, and what is the B value? The B value is 5. And let's now press equals to, then we need to check the answer. You see now, according to this calculator, already it has converted the angle. It has already calculated the angle as a positive one. Remember, it depends with the calculator. It depends with the, you see this one, it's root 34. Then the R, I'm saying this is the R, the theta, it's 120.96. So you need to be able to use your financial, your scientific calculator to convert from pole to rectangular and from rectangular to pole. For example, let's say now we want to convert, or we want to reverse the expression from polar to rectangular. So let me clear the information here. Shift clear. So now I see. Right. So it means now to do this, I have to say, okay, fine. Because now we want to convert from polar to rectangle. So I'm going to say shift rec, which is a minus there. Then look at this. With the rectangular, it means what do we want now? We want the theta. We need to look at the modulus and the argument. So it means now this time around, we're going to say, okay, fine. What is our modulus? Our modulus, the first one, it's root 13. So I'm going to say root of 13. Then what is the theta or the argument? It's 56.31. You see already by doing this, it's now giving me a vector to say whatever you want to get the value of R here, it's the X, which is the X. So it's, in other words, it's writing it in the form of X and Y. Right. Okay. Let me just erase this. So it's writing this in the form of X plus YI, which we know is the A plus B. So which means now what is the A? The A, it's 1.99, which is the same as 2. Then the B is 3 point, which is the same as 3. You see, it has converted from rectangle, from polar to rectangular, from polar to rectangular. Remember, it depends with the calculator. Some they show X and Y, some they show A and B. It depends with the scientific calculators. So you need to be able to convert from rectangular to pole and from pole to rectangular. So now you have seen on how to convert. We can even put the other one. For example, in other calculators, some they show this negative 59.04 instead of 120. For example, if we do this, let's say we have instead of putting, let me put 34 here, 34, not 35. Then the argument, let's now change this. The argument is 120.96. 120.96. You see now it's showing the R, the X and the Y. You see the X now it's negative 2.99, which is roughly negative 3, and 5.0 is the same as 5. But how about instead of putting the 120, then I put minus 59.04. Let's try the minus 59.04 and check if the answer is it not the same. So minus 59.04 and check if the answer is not the same. Minus, you see the answer? Oh, no. It's now changing this. In other words, it's changing the value of X now as 2 point, as negative, now it's positive. Because now, why is it doing this? It's because it's measuring from it is measuring from this side. Remember, it's starting from this side, going this side. So it means it's assumed that the value of Y is the one that is negative, and the value of X is the one that is actually positive. So it's measuring in the opposite direction. So it's very important to be able to understand this. But remember, it depends with the financial, I apologize. It depends with the scientific calculators that you are using. Remember, practice makes perfect. So you need to be able to convert these two. Right, let's now go back to what we have done already. Then now, I want us to continue. Remember, we have seen that we can write a complex number in a standard form, in a polar form, to be the r into cos of theta plus I sine of theta, which is the same as r cis of theta, or the r with the argument. So it's one and the same thing. Now, the question is, now, since we have seen on how to apply, to use complex number when we are adding, when we are subtracting, and when we are multiplying and under division, how about when they are in polar form? How do we deal with addition and subtraction of complex numbers, subtraction, multiplication, and division of complex numbers that are in a polar form? Let's do one example. Let me start with the addition. Number one, we have seen that, for example, if we say we have a z1 equals to, let's say it's r1, the c's, let me just say c's theta 1, and the second one, it is r2, the c's of theta 2. Remember, when I say c's, it means the cos I sine, so which is the same as r1, the argument. I'm saying the c's, this is the symbol for complex number, and this also can be written as r2, then with theta 2. Now, the question is, how do we deal with addition? How do we add complex numbers that are in a rectangular form? I'm saying polar form. Obviously, if we take z1 plus z2, this would be the r1 cis, which is the cos of theta 1 plus I sine theta 1 plus r2 into the cos of theta 2 plus I multiplied by the sine of theta 2. So it means if we expand this, we multiply in by the r1, this will be r1 cos theta 1 plus I r1 sine theta 1 plus r2 cos theta 2 plus I r2 sine theta 2, which means now we can group the like term, the real part with the real part and the imaginary. So it means this one, this two, it's a real one, and this one it's a, so it means you can combine r1 together with cos theta 1 plus r2 together with cos theta 2. Then the one with the I, these two, it means it's going to be r1 sine theta 1 plus r2 sine theta 2 with the same I. So you see that now we can do the addition, and we can also do the subtraction, which we'll talk about that. So it means in the context of addition and subtraction. So it means for subtraction, the application will still be the same, but now this time around, we're going to use this. Let's say with the subtraction, it means if it's a minus, it means this would be a minus here. Then when we group this, then we're going to have this, then this minus here, it will change these two. This will now become a minus, and this will now become a minus. So it means the only difference here, we're going to have minus, and there we're still going to have a minus. So it's very important to be able to understand that. But there are many ways to skin a cat. Right, how about if actually I wanted to focus more on multiplication and division? How about if we're dealing with multiplication? I want us to talk about this thing, multiplication. Right, in terms of multiplication, if we take z1, we multiply by z2, which means we are taking r1 cis theta 1, we multiplying with r2 cis theta 2. I want to show you something. So obvious in terms of multiplication, this we're going to have, we are going to end up having R1 and R2 being multiplied. So we take R1 and R2 multiplied. Then here, listen to me, here we're going to have C's of, we're going to add the argument. So we're going to have theta 1 plus theta 2. So in other ways, if we say this is R1, theta 1, we are multiplying with R2 with theta 2. The only thing is just to multiply the R value. So it's R1 multiplied by R2. Then this time around, we just add the argument. So it's going to be theta 1 plus theta 2. So this is what is called the multiplication. It's when we are dealing with multiplication. I will also prove to you why are we saying when you are dealing with multiplication for complex numbers that are in polar form, you just multiply the modulus and you add the argument, you add the angle, you multiply the modulus and you add the angle. That is what is called the multiplication of complex numbers that are in polar form. Then, but now how about when we're dealing with division? I'll prove this. So imagine we take Z1, we divide by Z2. So it means we have R1, C's of theta 1, we divide by R2, C's of theta 2. Now, according to the definition, according to division law of complex numbers that are in polar form, it says now you have to divide your argument. And after dividing your argument, you subtract the angles. So it means it will be theta 1 minus theta 2. Remember, it might also be as the R1 C's of theta 1. Remember, the C's is cos plus I sine over R2 C's of theta 2. So what you do, you just divide the modulus, then you subtract the argument. You subtract the argument, unlike for multiplication. For multiplication, you just multiply your modulus and you add the arguments. So this is according to the division law. This is according to the division of complex numbers that are in polar form. Then before I prove this, before I start to prove this, let me actually talk about something called De Moivre's theorem. Right, De Moivre's theorem says that imagine you have the following. Let's say we have the following. It's just an example. Imagine we have the following, guys. Imagine we have, okay, let me just write this as De Moivre's theorem. De Moivre's theorem. According to De Moivre's theorem, actually this has to do with complex numbers that are in a power form. So where we are dealing with actually powers. For example, imagine when we have z to the power of 2. Let's say the z now, it is the r, it's r C's of theta, which is the same as r C's of theta. So imagine when we have this is the same as making z times z, which is the same as saying r theta. We are multiplying the r theta. Look at this. What will happen if we were to use multiplication law? We know according to multiplication law, we multiply what? We multiply the modulus. So you see that the r and the r, when we multiply them, this will become r squared. And after multiplying the modulus, what do we do according to the multiplication law? We add the arguments. So when we add the argument, we're going to have theta plus theta. So you see that in terms of this, you're going to end up having this. You're going to end up having the r squared together with theta plus theta, this will become 2 theta. So you see that this will become r squared, the c's of 2 theta. But now the question is, how about if we have z to the power of 3? So you see that this will become the z times the z squared. And what is the z? The z is r theta. But what is the z squared? The z squared we already got with this one. It is the r squared 2 theta. We are still multiplying. What is going to happen? You see that we're still going to multiply the modulus. You see the r multiplied by r squared, this will be r to the power of 3. Then it means even the argument, you need to add them. So we're going to have theta plus 2 theta. This will give us the 3 theta. So you see we end up having r squared c's of 3 theta. But imagine when we have, let's assume we have z to the power of, let's say, 5. So this will become z times, let's say, z to the power of 4. Okay, let's just confirm something. Let's say we have z to the power of 4. Already z to the power of 4 will be z multiplied by z to the power of 3. Remember, with the z, this will be r c's of theta. But what is z to the power of 3? It's r cubic. It's r cubic c's of 3 theta. So let's do the same applies. We multiply the modulus. This will be r to the power of 4. Then we add the angle, so it will be 4 theta. So you see that in terms of De Moivre's, it says if we continue doing this, maybe for n time, what will actually happen? So it means it will now become this. Let me rewrite this. Imagine when we have z to the power of n, we have z to the power of n this time around. So if we have z or z to the power of n, it means now we're going to have this. We'll have the r of theta, but n of them. So it means this will become r to the power of n. Then we multiply the theta together with the n. So it will be n theta. So which is the same as r to the power of n, the c's of n theta. So you see that if we have 2, well, I'm saying n to the n, sorry. If we have 2, we're going to plug 2 there and we multiply. So it means we take the modulus, we raise it to the power of n, and we take the angle, we multiply by the n. So you see that if it's 3, it will be r to the power of 3, and the theta will be multiplied by 3. That is according to De Moivre's theorem. Actually, it works when we are dealing with the expressions that are in a power form. For example, let's say we have the following. Before I start, okay, it's fine. Let's just do an example. Let's just do an example. Imagine, ladies and gentlemen, imagine we have the following when we're given the following. Well, imagine they say evaluate the following. Evaluate the following expression. Evaluate the following expression and leave your answer. And leave your answer in a polar form. We need to leave the answer to be in a polar form. So imagine we have, let's say, 3 plus 8i to the power of 10. Imagine if you do this. Imagine if you do not want to use a polar form, you want to use a rectangle. So it means you have to expand this 10 times, which will be tedious work. So it means what we're going to do, we have to convert this. We have to convert this in a rectangular form. So it means we need to convert this to be in a polar form. Either you're using a financial or you're working, you're using a scientific calculator. But this time around, I wanted us to just do the calculation. But by looking at this, you can easily see that this is in the first quadrant. This is the A, and this is the B. So we're gonna say, look at this. Remember, we have 3 plus 8i. This is the A, this is the B. So we're gonna use theorem of Pythagoras. So r squared, it's x squared. You can also confirm using your calculator. So right, we're gonna have, what is the x here? The x is 3 squared, and the y it's 8 squared. So we're gonna have 9 plus 64, and 9 plus 64, this will give us 73. So we're gonna have r squared, it's 73. So what is the value of r? Okay, I apologize, guys. I just had some connection issues. As I was saying that we were given 3 plus 8i to the power of 10. By the way, what was the r, by the way? The r was the root of 73. Then let's now get the argument. The argument would be the second function tan of the b over a. By the way, remember I said it's 3 plus 8i. This is the a, and this is the b. So we're gonna say second function tan of, what is the b here? The b is 8 over 3. Then we can just say second function tan of, okay, second function tan of 8 over 3. Second function, the tan of 8 over 3. And since this is in the first quadrant, means the angle will be less than 90. So it's 69.4. Let's say 69.4 degrees. So now we can even confirm using our calculator, say the pole, the 3 and the 8, then it will still give us the same. So it means the r will be, here it says r it's 8.54, and the theta it's 6. So 8.54 is the same as the root of 73. So you see that we have now converted the rectangular to be in a polar form. So what is the r? The r is root 73. Then I can either write 6. What is the angle? 69.4 to the power of 10. And we know that this can be written as root of 73, the c's of 69.4 to the power of 10. And we know that according to De Moivre's theorem, it says if we have z to the power of n, where we have r of theta to the power of n, this is the same as r to the power of n, then you multiply the n by theta. So it means here we're going to say this is the root of 73 to the power of 10, to the power of 10. Then we now multiply the theta by 10. So it will be 69.4 multiplied by 10. Then now this would be the root of 73 to the power of 10. So this will give us, it's a bigger number. It's a bigger number. So we can just leave it as the root of 73 to the power of 10. Then we now multiply 69.4 by 10. Then that will be 694. 694. It's just an example, by the way, guys. It's just an example. So you need to be able to understand how to actually deal with De Moivre's theorem. All right, then now I wanted us to prove why are we saying when you are having complex numbers that are in polar form, when you are multiplying them, you just add, you multiply the modulus and you add the angles. And how about when you are dividing? You just divide the modulus and you subtract the angles. Remember, I want to repeat this. Let's say we have Z1, it's R1 C theta 1. Then Z2, it's R2 C theta 2. Let me confirm. Remember when we said when we have theta 1 and theta 2, we multiply. It means you're having R1 C theta 1. You multiply it with R2 C theta 2. Remember I said what to do? We just multiply the modulus and we add angles. We add the arguments actually, which is the same as R1, R2, sorry, then the C's of theta 1 plus. So I want to prove this. Look at this. Let's say we have Z1, we multiply with Z2. What is Z1? Z1, it's, if we were to write this, this will be, okay, fine. Let's just do this. This would be, let me just write this. This will be R1, C theta 1, and this will be R2, C theta 2, theta 2. Let's now multiply the modulus. Obvious, this one, this is the same as R1 times R2, but now we're going to remain with this. This is now the same as cos theta 1 plus I sine theta 1. I believe you are now following. You understand how I got that? So now theta 1. Then the second one, this also will become the cos of theta 2 plus I sine theta 2. Let's now remove brackets. We're going to have R1 and R2 into. We're going to multiply this with that one. So this will be cos theta 1, cos theta 2. Let's do the same. This one times that. This will become the I cos theta 1 sine theta 2. Then we do the same. This one times that. So it's going to be I sine theta 1 and cos theta 2. Then lastly is this one times that. This will be times I squared sine theta 1 and sine theta 2. Then we know that under the complex number, we know that I squared is equals to minus 1. So it means I can regroup this and say, it means here we're going to put negative 1 here. And look, when you put negative 1, it means this will now become negative. So we'll end up having the R1, R2. Then I'm going to group the real with the real. Remember, this is the real part. And also this, if we put negative 1, it will be the real part. So it will be cos theta 1, cos theta 2. Then this will now become negative sine theta 1, sine theta 2. Then plus, then these are also like term. We're going to take a common factor of I here. So it means this will become cos theta 1, sine theta 2 plus sine theta 1 cos theta 2. Then we close the brackets with the I. But look at this, guys. If we look at this, look at this. If you recall from grade 12, we used, there's something called compound angle. If you look at this, this is cos, sine, sine. And this is cos, sine, cos. You see that this one is a double angle, compound angle for cos. So it means this is the same as when we do this, is the same as we can just say. Remember, the double angle for cos, the one for subtracting, it was say, if you have this, no, for the plus, it was saying this is the same as cos x, cos y minus sine x, sine of y. So which means now we're gonna do this, ladies and gentlemen. So it means the expression now, this will remain, we're going to have this. It means this will be the R1, okay, apologies. So it means now we're going to have the R1. So this will be R1, R2 into, then this will become the cos of theta 1 plus theta 2. Same applies. This is the compound angle for sine. Remember, sine, sine, cos, sine. So it means this is the same as I, the sine of theta 1 plus theta 2. Because remember, compound angle for sine, it says sine, cos, sine, cos, then cos, sine. So you see that this is the same as when we just say R1, R2, then the C's cos I sine of theta 1 plus theta 2, which is actually the same as R1, R2 with the theta 1 plus theta 2. So you see that when we are dealing with complex number, when we are multiplying complex numbers that are in polar form, we multiply the modulus and we add the angle. But when we are dividing complex numbers, then what do? We divide the R, the modulus, and we subtract the angle. You subtract the angle, ladies and gentlemen. So it's very, very, very important for you to be able to understand that. But now I can just give you a hint, because due to time, to actually knowing on how to prove this. But as long as you know the application, even if you do not know how to prove, then it's not a big deal. Just here, I was just showing to you that you can be able to convert. I mean, you can be able to show why are we saying when we are multiplying complex numbers that are in polar form, we just multiply the modulus and we add the angle. But when we are dividing, you divide the modulus and you add the angle. Right, without wasting time, guys, let me take you through the problem solving. But however, guys, I'll just take you through the November 2021 question paper from the NCV 20 level 3 2011 question paper. I've just taken only the ones that involves the simplification, like the issue of polar form. Right, for example, if you look at this, they're saying simplify the following. But if you look at this already, ladies and gentlemen, this expression is already in a rectangular form. So to simplify this, if we were to simplify this, we know that the square root of any expression is that expression to the power of half. So it means this can be written as, to expand this can be written as 3 plus 4i to the power of half, then times 3 plus 4i to the power of 3 over 2. But look at these, guys. We know that, look at this two expression. These two expressions have the same base. It's exponent now. This is, remember, the score, I believe you understand this. So they have the same base. And how do you deal with exponents that have the same base? We take one base, which is 3 plus 4i, then we add the exponent, so it's going to be half plus 3 over 2, and this will become 3 plus 4i. And what is half plus 3 over 2? This is the same as 4 over 2, which is just 2. But since they did not say anything about whether we need to write it as a complex or we can just simplify this, this will be 3 plus 4i with another 3 plus 4i. Then we simplify 3 by 3, it's 9. 3 by 4 is 12i plus another 12i plus 16i squared. Then now this will become 9 plus, these are the like terms, this will become 24i plus, we know that I squared is equals to -1. So it means where there is I squared, we're going to put -1. It means this will be 9 plus 24i minus 16. Then we work out this. So obvious to write this in a rectangular form, it will be 9 minus 16, which are the like terms. This will give us -7 plus 24i. Remember, they did not tell us whether we need to leave the answer in a rectangular format or polar. So we just leave it to be in a rectangular form, but we can still convert to a polar form if need be. Depends with the question. So I strongly believe you are following. All right, let's now move on to the next question. The next question, it says 5 cis 120. 5 C's 120. We multiply this with 20 C's 60. Then we divide this with 4 C's 30. I believe you understand what we mean by C's. Remember, a C's just represent cos of an angle together with I sine of an angle. So now look at this. You see that this already, it is in a polar form. It is in a polar form, which we can write it as 5. It is the R. 5 is the modulus. Then what is the argument? The argument is the 120. The argument is the 120. We are multiplying with the R, which is 20. The argument is 60. And we also divide by the R, it's 4, and the argument is 30. You see that now what we're going to do here, we are going to expand this using multiplication law and also using the division law in a polar form. So we need to simplify this. Let's do the simplification, ladies and gentlemen. We know that according to the laws of complex numbers that are in polar form, what do we have here? We have the R and the theta. So I can just try to explain to say, this is the R here, it's R1, this is the theta 1, this is the R2, this is the theta 2, this can be the R3. So what do you do here? Since there is a multiplication here, what do you do? We apply, we know that when we take Z1 multiplied by Z2, when we have R cis theta 1, and we multiply by R2 cis theta 2, what do you do? We multiply the modulus and we add the angle. So we're going to do the same here. So it means doing the same, it means this will now give us the following. So it will be 5 multiplied by 20. So it's 5 by 20. Then now we add the angle. What is the angle? 120 plus 60. Then divide by, this time it's 4, and the angle is 30. So what is 5 times 20? Obvious, 5 times 20 will give us 100. So it will be 100 as the R, and the angle now becomes 180, which is the argument. Divide by 4. Then again, we know, you see, now we are left with division. And we know in terms of division, what do you do? If you have R1, theta 1, then R2, theta 2, what do you do? You divide the modulus and you subtract the angle. So it means this would be 100 divided by 4, then 180 minus 30. So you see that now we're going to have this. Then we're still going to end up with, so this will be, we're going to remain with 25, then with 100 and I'm say 50. But what if remember the final answer means will be 25 C's 150. But if they wanted the answer to be not to be in a polar form or to be in a rectangular, it means you're gonna say 25. I'm just adding here to say this will be the cos of 150 plus I sine of 150. Then what to do, we can just say 25 into, then we just say cos 150. What is cos 150? The cos of 150, this will give us minus the root of 3 over 2 plus sine of 150. I think this will be half. So this will be half I. Then we multiply this by 25. I mean, if they said we need to leave the answer in a what? In a rectangular form. If they said leave the answer in a rectangular form, it means this will be negative 25 over 2 root 3i plus then the other. But it only depends. But I think here we need to leave the answer to be in a polar form, ladies and gentlemen. All right, the next one, let's look on the next one. The next one is just the application. This has to do with forces actually. So it means we can apply, what is this? We can apply complex numbers in solving Newton's laws of motion, or especially in solving problems that are relating to forces, which is physical science. So if you look at this, they're saying calculate the resultant force. Calculate the resultant force. Now we're doing physical science. Calculate the resultant force in polar form for the following forces of system of force that are acting on a point. So you can easily see that if we were to expand this, it means we can write this in terms of a polar form. So it means this F1, in terms of polar form, its modulus would, from here to here, would be 8. So it will be 8 cis of 35 degrees. So this is what they have shown here. But the second one, this one, remember, it's the 50. So it means it's when we are measuring from anti-clockwise. I'm saying clockwise. So it means from clockwise, anti-clockwise, this will be 130. So you need to consider this. So it's 130 because 130 plus 50. So you see that the F2 here, the F2, it's 9 cis of 130. But they said, look at this. Just note the R, which is F1 plus F2. So already this, because this one is already given to us, it means we're just gonna say, because we know that R equals to F1 plus F2, then what is the R? The R is the 8 cis of 35. I'm saying the F1, sorry. And the F2, what is the F2? It's 9 cis of 1. You see, now we are adding, actually, this has to do with addition of complex numbers that are in a polar form. Addition of complex numbers that are in a polar form. So to do this, it means we're gonna replicate this. This would be, remember, it's 8 into, this will be cos 35 plus I sine 35. The same applies, 9 into cos 130 plus I sine 130. Remember, they said they want the answer to be in a polar form. Let's multiply by 8. This will be 8 cos 35 plus I multiplied by 8 sine 35 plus, let's multiply by 9. This will be 9 cos 130 plus I multiplied by sine 130. Then let's group the like terms, the real with the real. So it means this will be 8 cos 35 plus 9 cos 130 plus, we take a common factor between these. This is 8 sine 35 plus 9 sine 130. By the way, with the same I, we cannot leave the answer in this form. First of all, we need to use our calculator here. Let's use the scientific calculator to get the answer. It means we're gonna have 8 cos 35 plus 9 cos 130 is the first one. Obviously, this one will give us 0.7. Let's round to 4. This is 0.768 plus the second one. Now we are working out this. So this will be 8 sine 35 plus 9 sine 130, if I'm not mistaken. Then this will give us 11.48 3i. But look, they want the answer to be in a polar form. So it means we have now converted this to be in a rectangular form. Then to do this, it means we have to write this to be in a polar form. It means we are just going to use a scientific calculator. And within the scientific calculator, it means we're going to say Paul. We only need the A and the B. So we're going to say, okay, let me just confirm something. 8 cos 35 plus 9 cos 130. So this is giving us yes. So it's fine. So we're going to say shift Paul. We go to Paul, then we put the value of A. 8, 0.768. Then the B will be 11.483. You can confirm using your calculator. Then it means the final answer would be the R would be 11.516. Then the theta will be 86.17, which can still be written as 11.5 with the angle of 56 points. So it means if we were to talk about this will actually be regarded as the direction if we were to calculate. Then the magnitude here will just be the 11.5 Newton. So it's actually, if you look at this answer that we got there, we got 11.5 with 86.17. So if we do not want to use complex numbers, we can even solve algebraically, like what we have actually done. Like if there's a video that I've already created for how to calculate the resultant forces. We can also confirm this if we were to solve algebraically, just to prove to you that you can use complex numbers to solve problems relating to forces. Hence, I said complex numbers are important when you are dealing with, particularly in the field of engineering. For example, if we were to use the components, it means this will have you're going to have to use the tail to head. So it means this will be tail to head, and this will be, so it means this will be the F1X, and this will be the F1Y. So it means we're going to have the components of F1. So I'm just applying like in the context of physics. So this will be F1X, and this will be F1Y. So it means this will be F1. Then this one will use sine. No, this one will use cos. So this will be cos 35. This will be sine 35. So what is the F1? F1 is 8. So it's going to be 8 cos 35. Then 8 sine 35. Same applies with this. We can still do the same tail to head. And we do the tail to head. I just want to confirm the answer. F2x and F2y. So we have the F2x and F2y, which will be, these are the components, F2 and F2. This one uses cos 50. We can use 50, then use this sine 50. So what this is going to be 9 cos 50, and this is 9 sine 50. So let's just calculate this. What is the F1x? And what is the F2x? F1x, what is the F1x if we're using calculator? F1x will be 8 cos 35. 8 cos 35, it will give us 6.55 Newton. And where is it directed to? To the right. So you see it's directed to the right. Then F2x, this will be 9 cos 50. It will be 5.79 Newton left. So now about the F1y and F2y. So what is the F1y? F1y is this one. It's 8 sine 35, which is 4.59. Is directed, it's upwards. Then F2y is this one. It's 9 sine 50. 9 sine 50, this will be 6.89 Newton. Still it's upwards. So let's calculate the resultant. I just want to confirm the answer with you guys so that you can be able to understand what we're dealing with. All right, now we can do this. Let's calculate the resultant on the horizontal, the resultant horizontally and the resultant vertically. So it means we're going to calculate Rx and Ry. Let's start with the Rx. Rx, one is going right and one is going left. So we're going to subtract plus and minus. So it's going to be 6.55 minus 5.79. 6.55 minus 5.79. This will give us 0.76 Newton. Where is it directed to? It's directed to the right. Then now the upwards, they're both upwards, plus. Let's add them. 4.59 plus 6.89. So this will give us 11.48 Newton. And upwards. Look at this. I think we got from the complex, we got 0.768 plus 11.48. if I'm not mistaken. You see that this is to do with the Rx. So you see that the answers are roughly the same. Then we're gonna use tail to head. So it's tail to head, it's right, then up, then this is our resultant, and there is our angle, the angle of interest. So you see that this is the Ry, and this is the Rx. So we can use theorem of Pythagoras. So to do that, we're going to have 0.76 squared plus 11.48 squared. Then now, let's now do the square root. The square root of 0.76 squared plus 11.48 squared. Then now, okay, the square root of 0.76 squared plus 11.48 squared. Sorry, I did not put it inside the root sign. Squared plus 11.48 squared. You see, this is going to give us, the resultant would be 11.5 Newton. 11. You see, this is the R that we got here. Then this is the direction actual. So it means if we calculate the direction in physics, we're going to say second function tan of the Ry over the Rx. So which is the second function tan of, what is the Ry? Ry, it's 11.48. Rx, it's 0.76. So let's now calculate the angle. Second function tan of 11.48 divided by 0.76. So this will give us the answer of 86.2, which is roughly there. You see, it's 86.17. You see that you can, how important is complex numbers? Complex numbers are widely used, particularly in the field of engineering. Ladies and gentlemen, in the field of engineering, complex numbers are widely used, ladies and gentlemen. So you see that even if we have multiple forces, we can still use complex numbers just to simplify and get the answer. Imagine if we had lot and lot of forces that are actually acting, we can still use complex numbers to solve the questions, ladies and gentlemen. So number one, before I conclude, number one, we need to check this. We know that a complex number that is in a polar form, it must have the R, which is the modulus, the theta is the argument. So it's the same as R cis of theta, and the cis is just cos I multiplied by sine. And the issue of being able to convert from polar to rectangular, we went through that. And I strongly believe you have enjoyed the session, ladies and gentlemen. Thank you very much for listening. Thank you very much. Bye-bye.